going to talk about dissolved oxygen in the Magothy River, and specifically about low surface dissolved oxygen, which is something you don't hear a lot about. These pictures on the first slide show some local volunteers monitoring on Mill and Dividing Creek, and in particular notice this monitoring site in the lower right, which is a very flimsy floating pier that was sometimes touching the bottom. And that's one of the interesting things about the data set from Mill and Dividing Creek is we went to some incredibly shallow sites where to get water clarity you have to use the Secchi tube horizontally. So that makes for an interesting data set. So usually when you hear about dissolved oxygen problems in estuaries, it's about bottom dissolved oxygen. That's where algae fall when they die and decompose. However, there are some cases where there can be low surface dissolved oxygen, and we think this usually happens after an intense algae bloom or an input of some other organic matter that decomposes, and it essentially eliminates any fish habitat. There's just no place the fish and crabs can go to get oxygen. So I'm going to talk about volunteer collected data from the Magothy from three groups of sites. Three of these are sites that I've sampled. Two of them are creeks near my house. I started in 1991. There are 4 to 6 main stem sites that have been sampled since 2002. And then the 6 sites on Mill and Dividing Creeks where sampling started in 2006. And in order to compare the data, I'm only going to show data from 2006 to 2010. That gives us 5 years of data. And these are the sampling sites. The red sites are the main stem sites sampled by boat by a volunteer named Dick Carey. All of these except the one with the dot are over oyster bars. So he's very interested in oysters and has done oyster restoration and oyster monitoring. The one with the dot was one that I asked him to include because it's also the state station. It's always interesting to sample at the same spot the state does. The blue symbols are the ones that I've sampled since 1991 or 1992. Old Man and Cattail Creeks are the 2 upper creeks. I live on that peninsula. And then there's one site on Forked Creek way down here, which looks kind of lonely, but it's because we did a very extensive boat-based monitoring from 92 to 96. And I decided to continue one of those sites at a pier nearby. So that's sort of a holdover on the lower river. And then the data that I'm adding this year for the first time are the 6 sites in Mill and Dividing Creek. And that was a special study that was done after a sewage spill in Upper Mill Creek in 2005. Anne Arundel County wanted to find out what the conditions were and what kind of restoration might be needed. The sewage spill was in Upper Mill Creek here, right near College Parkway, and it was, I believe it was 3 million gallons of untreated sewage. And it was in December, but it's a very small creek, so it must have had some impacts. All of this monitoring is coordinated by the Magothy River Association, even though we don't have any paid staff. This is all volunteer. And all of it was funded at one stage or another by the Chesapeake Bay Trust. And what I did was I calculated, looked just at June to September data, which is when most low dissolved oxygen occurs. I calculated a separate surface DO status, how much of the surface dissolved oxygen was greater than or equal to 5. Then for the whole water column, the same metric, how much of the water column values were greater than or equal to 5. I calculated by year and by site, and then I calculated means over various groups. And what I expected was the surface status would be better than the water column status, simply because the surface is right next to the air, and you would expect it to be better oxygenated. And I found that in general it was. I also expected the creek sites to have worse status than the main stem sites, since they tend to have more persistent and intense algae blooms in the creeks, and they did in fact generally have worse status. And I'm exploring various ways to present the data. This will be included in the Magothy report card. It's going to be released on February 16th, so I tried a variety of different ways to show these results. And this is how dissolved oxygen data are often shown in what are called profiles, and these tend to be very busy and somewhat confusing. but these are from the Severn River. Pierre Hencart made these graphs, and they have depth on the y-axis and dissolved oxygen concentration on the x-axis, and the red line is at 5 milligrams per liter, and you can see that at both sites there were no surface values below 5 milligrams per liter. There was a very strong picnic line, especially at the mid-round bay site, SR5, where there was a dramatic drop in dissolved oxygen below somewhere around 3 or 4 meters. Interestingly, the upper one, SR2, is the same as the state station, and in the Severn it tends to have better dissolved oxygen conditions than several of the other sites that the Severn Riverkeeper monitors. And then this is a DO profile that I made for the Magothy for that MR6, that mid-river station that's also the state station. In this case, DO is on the y-axis, which is not how these are usually made, but I actually prefer it this way because I'm used to thinking of the thing you're measuring on the y-axis, and then depth is on the x-axis, the horizontal axis. And these look similar to the Severn graphs. There's also a similar depth, about 6 to 7 meters. There's also a picnic line, about 3 meters, if there's a dramatic drop. But what's really interesting is to see how much the dissolved oxygen varied even in 1 week. The worst surface conditions that Dick measured were on August 24th, and a week later had the absolute best surface conditions that he measured. And this shows why weekly sampling is important, and in fact, if he'd sampled daily, he probably would have captured more variability. But the general pattern is the same, with higher surface levels and lower bottom levels, down near zero for a number of dates. But of course, this is not the sort of graph you put in a report card. Nobody would finish it. So Pierre and I and others have looked at other ways to summarize dissolved oxygen data that are more accessible. This is a figure that Pierre Hencart made that I really like, where he combines a map showing the station locations with a graph below it where they correspond. This works really well for a long, skinny river like the Severn. It doesn't work as well for the Magothy. But what he did was he summarized status, the mean percent of water column, DO greater than 5, the same metric that I use. And this is the sort of standard report card metric. And you can see a gradient along the river where the worst sites are here in the middle. The bars show variability by year, so there's a little bit of variability by year, but not too much. These are the 2 sites that were shown in the previous graph, and you can see that SR2, the state site, had much better status than any of the sites in the middle of the river. So in choosing that site, the state got a place that's much better than most of the river for dissolved oxygen. And these are just some very simple graphs that I've made for the Magothy. I haven't decided yet exactly what I'll use in the report card, but I broke it out by the 3 groups of sites, which I've never done before. This is the same metric as in the last graph, the percent of water column dissolved oxygen greater than or equal to 5. For the main stem, it was around 75 to 80% for all the last 5 years, which is pretty good. And then intermediate were the 3 sites that I sampled, including the 2 near my house. Those were around 50%. What you can't see in this kind of averaging is that one of them, Cattail Creek, was much worse. So there's some variability hidden there. And then the green is the sites in Mill and Dividing Creek, and they dropped down as low as 20% status. And if we go back to the Severn, that's as low or lower than the worst sites on the Severn. So it's definitely, Mill and Dividing Creek definitely have very poor dissolved oxygen status. And then I made a similar graph of just the surface status, and as you expect, the whole graph is shifted upwards because we're just looking at surface layer. The main stem, 95 to 100%, very good status. The 3 creeks that I sampled were intermediate, about 75%. And then Mill and Dividing Creek, and I was quite surprised to see this, only about 40%. That means in many years, 60% of the surface samples have dissolved oxygen less than 5 milligrams per liter. And that's, I didn't realize it could be that high. That's very high. So there's definitely something going on in Mill and Dividing Creeks. So naturally, I looked at the raw data, and this is the sort of thing you do on your own, but you also don't put things like this in your report card. But you can see that for Mill and Dividing Creek, there was one site in particular, M2, where the average surface status over all years was only 10%. And there were 2 years where it was 0%, same for D1 and M1. They all had years where not a single DO reading was over 5 milligrams per liter all summer. And in comparison, the main stem was very good status, and the sites I sampled were mixed. What's interesting is I thought M9 is cattail. I was pretty sure that was the worst site in the whole river, but that was because I hadn't really looked at the Mill and Dividing Creek data yet. So, you know, and I've sampled here for it'll be 21 years, I think, or at least, no, 20 years at these two sites, and yet I just, you know, I didn't know about Mill and Dividing Creek because I hadn't been there. So, what you see in the Mill and Dividing Creek data is a lot of variability by site. You had anywhere from 10% to 58% status, and these are small creeks. So what I did is to show the mean status by year on a map, which is a lot easier to understand. I think this is probably what's going to go into the report card. So what you see is that the main stem samples sampled by boat, plus this sample where I sample from a pier, were all in the best category, 80 to 100% status. The two sites near my house, one was in that same category, Old Main Creek, and Cattail Creek, which I thought was the worst, was only in the third category, 40 to 59%. And then within Mill and Dividing Creek, you had red, the worst category, you had purple, the next worst, and you had yellow, and you had blue. So you had 4 of the 5 categories just in Mill and Dividing Creek. And just to give you a sense of scale, the tidal portion of each of these rivers is only about 0.8 of a mile. So that's very short. And I think this has implications for sampling design. How do you know how many samples you need? In this case, you probably need a lot. But you can definitely see the red and the purple are the uppermost sites in both creeks. So why is Mill and Dividing so bad? And the easy answer would be, well, it was the sewage spill. But if you think back to the data, 2006 was not even the worst year. That was the year after the sewage spill. 2007 was the worst year, but it's basically been bad every year. So it can't be as simple as the sewage spill. The worst conditions were the farthest up the creeks, so that may be a factor. You saw that picture of the sampling where you're almost on the bottom. And very few people sample that far up at Tidal Creek. It's really hard to get to. It's really hard to sample. I think one thing that's happening is that at low tide, the water there is actually a pool. It's separated. It's not connected anymore. And so it's sort of like a stagnant, warm pool, and that's not a good formula for dissolved oxygen. And there may be something about the configuration of the mouth of the two creeks. I'm not sure, but it's really been an eye-opener for me. So what this means for sampling design is that you can have a lot of spatial variability in a very small creek. It means that you can't just look at a map and pick some typical creeks to sample and assume that everything else is similar. You may need 3 sampling sites over 0.8 of a mile of creek, which is a lot. If you put that in every creek on most of our rivers, you'd far exceed your sampling capacity. And I said for years that the creeks farther upriver should have worse water quality because Cattail Creek was one of the farthest upriver that I sampled, and it had the worst water quality. But here we have Old Man is in the best category, and then Mill and Dividing, which are sort of in the middle of the river, were by far the worst. But just to put this in perspective, I've also done monitoring on College Creek on the lower Severn for several years, which is about the same size creek, about 0.8 of a mile long, and there's almost no difference in DO status at all along that creek. So again, you can't assume that all little creeks are going to show this amount of variability. In fact, in College Creek, I think we have 6 sites, and I think 2 or 3 would be plenty. So yeah, there's always the danger of oversampling as well. And I wanted to thank the Chesapeake Bay Trust, who really couldn't have done this without them. They paid for most of the equipment. a whole slew of volunteers that have helped, and Pierre Hancock's done a lot of work on this too, so I appreciate the work he's done. Thank you.